Good morning to all. Good morning to all. Today we are going to discuss about the Unit 4 data quality and standard. The topic is thematic accuracy and lineage metadata. The course outcome of this topic is interrupt the concept of data quality and standard. The program outcome of this topic is 1, 3 and then 5. The program specific outcome is 1. The outcome of this topic is interrupt the concept of data quality and standards. Data quality and metadata. The purpose of any GIS application is to provide information to support planning and management. It is also intended to reduce uncertainty in decision making. The acquisition and processing of spatial data should be able to access the quality of database base data and the derived information procedure. Most spatial data are collected and held by individual specialized organization. Some base data are generally the responsibility of the various governmental agencies such as the national mapping agencies, which has the mandate to collect to geographic data for the entire country. Organizations, geological survey, energy supply companies, local government and many others maintain spatial data for their own particular purposes. ISO consideration quality to be the totality of characteristic of a product that bear on its ability to satisfy a stated and implied need. Quality is often defined as fitness for use. The International Cartographic Association's commissions on spatial data quality, along with many national groups, has identified lineage, temporal accuracy, completeness, and logical consistency an essential aspect of spatial data quality. Traditionally, errors in paper maps are considered in terms of attribute errors in the classification or labeling of features. Errors in the location are height of features greater than positional error. When applied to spatial data, error generally concern mistakes or variations in the measurement of position. It is also important to distinguish between source data and processing errors resulting from spatial analysis and modeling operations carried out by the system. Errors in data transformation, datum transformation, data conversion, accuracy and precision. Measurements errors generally described in terms of accuracy, the closeness of observations, computations or estimates to the values or the value perceived to be true. In spatial data, accuracy may relate not only to positional error but also to the measurement of quantitative attributes data. Precision Precision, which is a statement of the smallest unit of measurement to which data can be recorded. Accuracy and precision are closely related. In GIS, numerical precision of computer processing and storage usually exceed the accuracy of the data. Attribute accuracy. In case of remotely sensed data, however, considerable effect may be required to assess the accuracy of the classification procedures. This is usually done by means of checks at a number of sample points. The field data are then used to construct an error matrix that can be used to evaluate the accuracy of the classification attribute. The field data are then used to construct an error matrix that can be used to evaluate the accuracy of the classification. The classified image, forest, agriculture, urban total. The forest, agricultural, urban total, the waste, the based the error matrix accuracy is equal to the calculation we can make. So temporal accuracy, remotely sensed data has increased enormously. So this data can provide useful temporal information such as changes in land ownership and the monitoring of environmental process such as deforestation. The positional and attributes components of spatial data may change together or independently. lineage. It describes the history of data set, that part of the data quality statement that contain information that describe the sources of observation of materials, data acquisition and compliance methods, conversion, transformation analysis, and derivation that the data has been subjected to, and assumption and criteria applied at any stage of life. So, if no lineage information is available, it is not possible to adequately evaluate the quality of a data set in terms of fitness of user. The completeness, data completeness is a general understood in terms of omission error. The completeness of a map is a function of the cartographic and other procedure used in its compilation. Spatial data management system, GIS DBMS, accommodated some form of incompleteness, and this form come into two flavors. So lack of data, like failed to obtain measurement, attributes incompleteness, we cannot know everything all of the time. So database allow to administrate unknown attribute values are being null valued. So positional incompleteness, knowing measurement values but not or partly knowing to what portion they refer. So the completeness is closely linked to logical consistency, which deals with logical rules for spatial data. The rules of data consistency are dictated by the specific application and deal with value ranging and allowed combination of values. The rules are defined before any data is entered into the system, as this allows the system to guard over data consistency from the beginning. A spatial consistency rules, the municipality territory is completely partitioned by mutual non-overlapping parcels. A temporal consistency rules, any date stored in the system is valid date that falls between Jan 1st 1990s and today. A spatio-temporal rules, historic parcel do not mutual overlap in both valid and spatial extent. So, geographic information infrastructure. In recent years, geographical information system and enterprises have continued to evolve towards distributed models in order to better exploit the potential present by the internet computing paradigm. The term spatial data infrastructures is often used to denote the relevant base collection of technologies, policies, and institutional arrangement that facilitate the availability of and access to spatial data. An infrastructure is a kind of organization which is the main basis for other organization organizing activity developments, contributes necessary and different activities is sustainable development. So the SDI provides a basis for spatial data discovery, evaluation, and application for users, and provides within all level of government, the commercial sector, the non-profit sector, academia, and by citizens in general. Spatial data infrastructure encompasses the resources, systems, network linkage, standards, and institutional issues involved from many different sources in delivering geospatial related information to the widest possible group of potential users. So in 1906 created US Geographic Board. The 1919 created a new board of surveyor and map that took over the responsibility of US Geographic Board. The 1953 descriptive responsibilities, that is a federal agencies. The 1967 better description responsibility of federal agencies. Then 1983 the cartographic data program. The 1990 more program are established in the committee and links. The 1994 established the national spatial data infrastructures. So balancing the geographic information generation and utilization concentration is the main evaluation resulted in new STI definition as follows. So product based model, then process based model. The STI hierarchy: process based model, product based model, global STI, regional STI, national STI, state STI, local STI, corporate STI. So this is the hierarchy we have to follow in the similar orientational structural pyramid. So from each level we could navigate to its upper and lower level. Each lower level provides the building blocks of upper level. Each upper level transfer its overall definition and background strategy policy to lower level. The level relationship fastens as they come closer. So what is the national spatial data infrastructure? The things we are going to discuss on next session.